Okay, good morning, everybody, and welcome to our class for today. We will be looking at Mapwork calculations. So this is a very serious section that you need to worry about in all of your grades. This is where you can bank a lot of your marks. Remember, with your Mapwork calculations, you get a mark for your formula, you get a mark for showing your calculations, and then you get a mark for your final answer. So these questions can be out of about 5 or 6 marks sometimes. So it's very important that you focus on this section because this is where you can either make it or you can break it in your Mapwork paper. The first one that we're going to look at is your conversion table. This is a very important table to know. I've included it for your own safekeeping. This table will help you to be able to move between your units from millimeters to centimeters, meters, and then finally kilometers. Sometimes we need to compare apples to apples, so you need to have the same units in throughout your entire question. So you're going to need to sometimes change centimeters into meters and vice versa. So here this table gives you a very good example showing you how you can go between each unit to help you to get those like units. You want to compare apples to apples and oranges to oranges. So the first calculation we're going to look at is going to be your distance. So here is the distance formula. Remember, like I said, you're going to be tested on your formula. So please, you need to learn these formulas so that you are able to write them down when you are writing your test. The distance formula is distance equals your map distance, so the measurement on the map, times the scale of your map, all over 100,000. So let me break it down a little bit further. Your distance is going to be the distance that you measure on the actual map times the map scale, generally found at the bottom, all over 100,000. And that will be able to show you your distance in kilometers. So let's look at an example. If you get a topographical map in your exams one day, and it says, what is the distance from Trigbeacon 352 to the Kirsten Dam? So you're going to see the distance from this Trigbeacon over here in block A1 to the dam wall here at Kirsten Dam. So that is going to be your question. So the first thing you're going to need to do is take your ruler, put it up against this Trigbeacon and put it to your dam wall, and you need to measure your distance between these two different points. So let's look at this example. So if you need to calculate the length, or we're going to use my example that I used, your distance that we looked at on that map. If we measured that from point A to point B, and we measured 4,8 centimeters, that was our map distance. So now that we have our map distance, we can now put it into our formula. So here our distance formula is map distance times your scale all over 100,000. So we need to put in our values. So we bring down the measurement that we took on the actual map, 4,8 times 50,000. That would be your map scale for your topographical map, all over 100,000. You do this in your calculator and it will give you an answer of 4,8 over 2. And eventually you will get the answer of 2,4 kilometers. That is your final answer. So the distance that you measured between point A and point B would be 2,4 kilometers in reality. Okay, so in real life. Please, like I said, do not forget to put your units at the end. We need to know what you are measuring. I cannot tell you to go to the shop. It's only 2,4. You need to know how far away it is. It is 2,4 kilometers away. The next formula that we're going to look at is going to be your area formula. Our area formula is your area equals your length times your breadth. Very, very similar to your mathematical formula of your area. It's length times your breadth. So looking at this formula, if we gave you a map, if we gave you a map and we said you need to measure this block over here, okay, you need to measure this block on the map and say what its area is. You're going to need to use your area formula. So the way in which we use our area formula, we are given this block at X. We need to first work out the length of your block. We want to know what's the length and what is the breadth. So we measure our length first, and that is going to be 5 centimeters. But it's not really 5 centimeters in reality. It's only 5 centimeters on your map. So you're going to need to tell me what is the distance in reality. So we need to use our distance formula. So we put this length into your distance formula, 5 centimeters times your map scale, all over 100,000. And that will give you an answer of 2,5 kilometers. So this length in reality is 2,5 kilometers. Now that we have the length, we need to know what the breadth is. So again, we need to measure this block on our map, and that will give us an answer of 3 centimeters. But it is not 3 centimeters in real life. We need to put it into our distance formula to see how far it would be in reality. So we put the 3 centimeters times your scale of your map, all over 100,000, and that gives you an answer of 1,5 kilometers. So your breadth is 1,5 kilometers in real life. Now that we have our values, we've got our length and we have our breadth. Now we are able to put it into our area formula. So we do it quite simply. We bring down our length from the top, 2,5 kilometers, and we bring down our breadth from the top, and that will be 1,5 kilometers. You put that into your calculator, and it will give you an answer of 3,75 kilometers squared. Please, again, do not forget your units. This is going to be measured in kilometers squared. Okay, and the last formula that we'll be looking at today is going to be your gradient formula. Your gradient formula is going to be your gradient equals your VI over HE. But what does VI and HE stand for? Your VI is your difference in height. So when we're looking at your gradient, we want to know how steep the slope is going to be. If this hiker at the bottom over here, he just leaves his car and he wants to go hike up the hill to this house at the top where he can look out over the valley. He wants to know how tough is it going to be walking up the slope. So he wants to check what the gradient is. So that is your steepness of your slope. So here, to put this into our calculator, we need to work out the difference in height. So if this is 0 meters and this is 100 meters, The difference in height is going to be 100. Okay, so that is your VI, the difference in height. Your HE is your horizontal distance. So how far is he going to walk in order to get to this height? We want to know the distance. How far is he going to go? That will give you your gradient of your slope. So let's look at an example. If we again give you this and we say, okay, your hiker is at the bottom of the slope here at Sonneskane, and he wants to walk up to the trig beacon at this point over here. Okay, don't take the values for example, I'm just giving you a case study. If he wants to walk up this mountain, he wants to know what the gradient is going to be. So how steep is the slope going to be? So we can use our gradient formula to find that out. Sorry, I just want to fix this first before we get going. Okay. All right. So we need to know our gradient. But our formula, like we have said, is going to be your gradient equals your H. Is going to be your VI over your HE. So when we look at this, we want to know what is the difference in height over the distance that he is walking. So now we know what we need to look for in order to complete our formula. We need to look at what is the difference in height first. So we see that point C is at 340 meters above sea level. And we see that point D is going to be 460 meters above sea level. So we need to minus the smaller one from the big one. And that is going to give you a difference in height of 120 meters. Okay, now we've got VI. Now we need to find HE to complete the formula. So we need to find what is the distance between these 2 points. So we put our ruler on our map and we take that measurement. The measurement that we found was 4,8 centimeters. So we take this 4,8 centimeters and we need to put that into our distance formula. So our distance formula, we write it down to show that we know what we're doing. So we put map distance times your scale all over 100,000. That will, you take down the 4,8, which is your map distance. You times that by 50,000, that is your scale of your topographical map. And you put that all over 100,000. That will give you an answer of 2,4 kilometers. But now look what's going on. We have this answer in meters and we have this answer in kilometers. So they are not the same units. So we have a problem. We need to change this distance into meters. So the way in which we do that, again, like I said, you need to keep your distance table very close to you. Okay, sorry, your conversion table very close to you. So here we can see, okay, we're going from kilometers and we want to know what it's going to be in meters. So we need to times that answer by 1,000. Okay, so now that we know that we need to times this one by 1,000 to get them into the same units, we always want to compare apples to apples. So we times 2,4 by 1,000. And that will give you an answer of 2,400 meters. Okay, so that is how far you are going to be walking. So now if we look at our gradient formula again, gradient equals your VI over your HE. And we look at what we need. We have found the difference in height. And we have found the distance between those 2 points. So now we are able to use our gradient formula. So here, our gradient formula, your difference in height over your distance between the 2 points. We bring down your 120, which was your difference in height. We bring down your 2,400 meters because that was your distance between the 2 features. And we put that into your formula. Now we are able to determine what your gradient is going to be. So the way in which you do this, very important to remember this and not to just put it into your calculator. You need to divide the bottom one by the top one. You want to get it out of 1. We need to turn it into a ratio. So you divide the bottom one by the top one. So 2,400 divided by 120. And that will give you an answer of 20. So again, we want to make it a ratio. So you put 1 over 20. And again, you bring it down to be 1:20. Okay, and that will give you your final answer. But what does this mean? If we say that your gradient is 1:20, what does that really mean in real life? What it means in real life is that every meter or every 20 meters that you are going to walk on the Earth's surface, you are going to rise up 1 meter in height. Okay, so for every 20 meters that you walk, you will get higher in elevation by 1 meter. So that is not too steep at all. But if I had to give you another example, and I had to say your gradient is going to be 1:5. Now, what does that mean? That means that for every 5 meters that you walk, you are going to go up by 1 meter. So it's going to be much, much steeper now compared to your gradient beforehand. So the smaller the number, the steeper your gradient. The bigger your number, the more gentle your gradient. Please, they do love to ask that in your tests and exams, so please be able to explain your gradient. The first one, the answer that we got is 1:20. So it means that for every 20 meters that you walk on the ground, you will rise up 1 meter in elevation. So it's quite gentle. Our second example of a gradient was 1:5. Here, that one means that for every 5 meters that you walk on the ground, you will be rising up in elevation by 1 meter. So it is much, much steeper, harder to climb, and it will require more energy. All right. Thank you, and let me know if you need any assistance or any help. I am here for your guidance, so please do send me any messages. Thank you, everybody, and enjoy the rest of your day.